door access control via Bluetooth system. Let's assume you're making use of your mobile phone as the input device. Now, your mobile phone sends a Bluetooth signal. It's actually paired with this Bluetooth module. In your project, we're making use of an earpiece as the Bluetooth module, Bluetooth earpiece. Now, when you press the buttons on your mobile phone, what happens is it generates the keypad sounds. Now the keypad sounds is actually DTMF tones being generated. Now the tones are sent through Bluetooth to the Bluetooth earpiece. The output of the earpiece is connected to the tone decoder. The tone decoder converts the sound, that's the tone, to binary numbers in which the microcontroller can understand. Now, the output of a Bluetooth module is analog signal. Now, the output of the tone decoder is digital signal. The microcontroller can understand the digital signal. So, what the tone decoder does is just to interpret as it tells the microcontroller which button was pressed on your phone. Now, when the microcontroller receives the signal, it acts on it. Now, 0 is to open the door. Okay, 0 to open, okay, 1 to open, then 0 to close. Now, it sends a logic. There should be a arrow here. Oh, it sets. Whatever. It sends the iLogic. It sends the digital now. It sends the digital signal to the microcontroller. The microcontroller compares it with whatever is stored in it, the password that is stored in it, while you program the chip. The initial pre-stored password is stored in the EEPROM of the microcontroller. Now, the tone decoder, it compares it with whatever the tone decoder receives from the Bluetooth module. Now, if there is a match, it sends a high logic to the relay, which activates this relay. Now, the relay activates the DC motor and opens the door. Now, if it's a wrong password, the microcontroller activates the alarm and the modem, more like a call. This is your Bluetooth circuit. The tone is received, filtered by C1. The audio level is reduced because if it's too high, it's going to give error at the output. Now the crystal is used to generate the frequency needed to decode the signal, the tone coming in. This determines the response time, how fast the tone is being decoded is determined by this resistor, and capacitor is like a RC circuit. And okay, the microcontroller also has a crystal which generates the operating frequency. This is your relay circuit. Let's go straight to the complete circuit. Okay. The tone is received here, decoded by this circuit, sent into the microcontroller. The microcontroller compares it with the pre-stored password and acts on it. If there's a password match, it activates sends the iLogic to this Q1. Q1 activates the relay activates the motor, the door is open. It waits for some seconds, let's say like for the person to access the door, and sends a low logic which shuts the door. Now if the password that was entered is wrong, a low logic is sent to the door, which means the door remains closed. A high logic is sent to the Q2, and Q2 activates the relay RL2. This relay, the relay activates the call button of the modem or your mobile phone. A mobile phone inserted in the project used as a modem. It activates the last dialed number. It's also sent a iLogic. The microcontroller sends a iLogic to the booster circuit to activate the alarm. It's going to ring, probably activate the alarm for about 30 to 1 minute, and deactivates the system. Okay, so this is your final complete circuit.